Hello and welcome to your geometry recording. We are in week 11 and today is officially the first day of spring. So welcome spring. And typical Colorado spring fashion, we've been seeing all sorts of seasons recently as we head into spring, and I'm sure we will continue to. But we are headed into the spring season and the end of the school year, so that's pretty exciting. Make sure you've got your math notebook out and you're ready to take good notes. I'm going to do 2 warm-up problems today, and these problems should look pretty familiar to you. So what I did is I grabbed 2 problems that I had a couple of questions about from several students last week, and I changed some numbers to them. So looking at the first warm-up question, I want you to find the length from A to B. From A to B. This is point D right here. That's point D. So from A to D is 8. And from C to B is 62. And I want you to find the length from A to B. And my hint to you is that you will need to draw in a segment to create a triangle, a right triangle, so that you can solve that. So that's the hint for number 1. And then the second one is find the measurement of angle Q. So we want to find this measurement right here, the measurement of angle Q. The measurement of this angle is 50 degrees. So use that to find the measurement of that right there, that angle. So go ahead and click pause. And this is a great review from some stuff we did in the beginning of Unit 7. You will have a Unit 7 quiz this week, so this is some great review to get you prepped for that. So go ahead and click pause and try these on your own. Again, you're going to get so much more out of these recordings if you actually are clicking pause and trying stuff on your own. So go ahead and click pause, grab your math notebook, try these, and when you're ready to check your work with mine, go ahead and click play. Alrighty, so I believe these all are coming from Unit 7, Session 1. We learned about segments and lines that either intersect circles or are tangent to circles. So one of the things we learned is about tangent lines. So a tangent line is a line that intersects the outside of a circle in one place. So this line here is tangent to the circle, and we intersect the circle right here at that point. We also learned that if a line is tangent to a circle, which we have, and then we draw the radius in from that point of tangency. So a radius, remember, you go from the center of a circle to the outside. So if you draw in a radius from the point of tangency, it is going to intersect at 90 degrees. So we have a 90-degree angle right there because of that theorem we learned. If you draw in a radius from the point of tangency, so here's our radius, intersects the side of the circle at the point of tangency, then it's going to intersect that tangent line at a right angle. So now I've created a right triangle, haven't I? I've created a right triangle. And, oops, I think I'm missing a side measurement that I did not give you guys. Nope, just kidding, I actually did label this right. So, do we know the radius of this circle? So look here, from A to D, it's 8 units. That's the radius. So if this distance is 8 units, this one also has to be 8 units. The radius is the radius. It's going to be the same measurement anywhere I would draw in a radius. So if from A to D is 8, that means from A to C also has to be 8. So now I don't know the length from A to B, nor do I know from D to B. So I'm going to treat A to B as my unknown. I'm going to call that X. So from A to B, I'm going to call, we're all the way from A to B, I'm going to call that X. And I'm going to use the Pythagorean theorem to solve, because I know that if we have 2 known sides in a right triangle, we can use the Pythagorean theorem. A squared plus B squared equals c squared, with c squared always being your hypotenuse. Now remember, the hypotenuse is always directly opposite that right angle, so we're going to call that x squared. Then I've got one side is 8 and my other side is 62. Pretty big. All right, so let's go ahead and do that. So we've got 8 squared plus 62 squared is going to equal, if we put all that together, 8 squared is 164, 62 squared is, so you're going to have 64 plus 3,844 is equal to x squared. Combine those, add those like numbers, so we're adding 3844 plus 64, and I get 3906. 3,906 equals x squared. Then we want to solve for x, so we're going to take the square root of both sides to undo that x squared. Take the square root of 3906. And I get, hold on, x is equal to, I'm going to do 62.5. I'm going to round to one decimal place. And that is kind of a strange one, that because that one side length was so long and the other one was so short in comparison to it. I don't know why I picked 62. I should have picked a smaller number. I'm not quite sure why I did that. But this is what we get when we do the math. So the length from A to B is going to be equal to 62.5. So from A to B is 62.5. So if I wanted to find the length of DB, I could do that then, right? I would take the entire length, 62.5, and subtract 8 from it, and that would give me the length of DB if I wanted to find the length of DB, because I know the entire length now is 62.5. All right, and then on to the question about the measurement of angle Q. So this measurement right here. So remember what we learned, that is if you have a line that is tangent to a circle, and if we draw in the radius, starting at that point of tangency, if we draw in the radius, remember it's going to intersect at 90 degrees. So we would have a 90-degree angle right here and here. There's 90-degree angle. So what I'm going to do is I'm going to draw in another segment. Got a lot of colors going in here. If I draw in a segment from there to there, I've created a triangle. And we know that this side here and this side here, so PS and SRP, are congruent, right? Because these are both tangent lines. And if you have two tangent lines that start from the same point, then you know that those segments are congruent. So I've created an isosceles triangle, right? I've created an isosceles triangle. So we know the angle, these two angles here have to be the same angle. So there's a total of 180 degrees in a triangle. If one of our angles is 50, that leaves 130 degrees between those two angles. And they have to be the same measurement, so I'm going to divide those by 2. And I know then that I get 65. So these two angle measurements have to be 65 degrees. 65 degrees. Now remember, gosh, I've got hardly any space here. This angle here is 90 degrees. So then behind, we've got another triangle here, and we're trying to find that angle right there. So we've got some help here. Remember this intersection here is a 90 degree, where our radius intersected with our point of tangency was 90 degrees, and we split it with a line here to create a triangle. So if 65 degrees is being taken up of that 90 degree angle, how much does it leave behind for this angle right here? Well, 90 minus 65 is 25, and these two angles have to be the same. So this angle here, I'm going to draw in an arrow. Goodness, I really don't have a whole lot of room. So this angle here is 25, and this angle up here is also 25 degrees. So this angle right here, I don't have a whole lot of room to put it in there. And then there's a total of 180 degrees in a triangle. So to find that last remaining angle, angle Q, I would just take 180 and subtract out 25 and 25. And what do I get? 50 here. So 180 minus 50 is 130 degrees. And if you notice, there's a pattern that occurs between this angle here and this angle here. They always have to add up to 180 degrees. So if this one is 50, this one's going to be 130. So if you need more time, go ahead and click pause. Otherwise, I'm going to move right on. So that was a great warm-up, especially for reviewing everything we've learned in Unit 7 so far, in sessions 1 through 3, because we're going to start this week with a quiz that covers sessions 1 through 3. So we learned about different segments in not triangles, in circles, chords, tangents, secants. Then we learned about arcs and chords and arc measures. And then we learned about sector area and arc length. So all that's going to be on the Unit 7 quiz. And then this week we're going to move on to inscribed angles and angle relations in circles. So because of time constraints, I'm really going to only have time. We did a lot of review for the beginning of Unit 7 in our warm-up. So we're really going to focus in this recording on inscribed angles. So that's going to leave Unit 7, Session 5 for you to really dive in on your own. Spring break next week. Woohoo! That's pretty exciting, right? So spring break is next week, but what is pretty cool is that Schoology is available for you to work over break. I am not available, so if you email me over spring break about a question, I won't get back to you until after spring break. But what an awesome opportunity for you if you are behind in the class to work on getting caught up. So after spring break, we're going to come back and we're going to be in April, and the end of the school year is in May. So it's going to come quick. So now is the time to get caught up if you are behind, and using that opportunity of Schoology being available to you over spring break. All right, inscribed angles. So inscribed angles are angles that are inside a circle. So any angle that's inside a circle is called an inscribed angle. And if you have a vertex of an angle that sits on the outside of a circle, so look at all these examples. Every example, the vertex sits on the circle. It sits on the outside of a circle. If you have that, if that is the case where the vertex is on the outside of the circle, then to find the measurement of that angle, you're going to use this formula right here. That measurement of that angle will be equal to 1/2 the measurement of the arc that it intercepts. So remember, the arc is the outside of the circle, so it's going to be 1/2 this measurement right here. So look down here. I've got a circle. I've got an inscribed angle with its vertex that sits on the outside of the circle. And the measure of this angle is 20 degrees. So knowing what I just told you about how to find the measure of your inscribed angle, do we know the measure of the arc AB? Well, sure we do. Remember, the measurement of the angle is going to be 1/2 the measurement of the arc. So 2 times 20 would be 40. So the measurement from A to B, that arc has to be 40 degrees. And then we would take 1/2 of that, which is 20, to find the measurement of the inscribed angle. That's it. So that's if our vertex sits on the outside of a circle. So let's look at another example. And I want you to look at this circle. There's some inscribed angles with angle measurements given, and an arc from A to D of 94 degrees. Can you find the measurement of angle C? Go ahead and try this on your own, and then when you're ready to check your work with mine, click play. All right, so we know that the measurement of angle C is going to be 1/2 the measurement of arc AD, which is given. So half of 94 is going to be our answer. 94 divided by 2 is 47. So if you said you chose A of 47, you are correct. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so we have learned how to find the measurement of an angle if the vertex is on the outside of the angle. So using that theorem, what I want you to do is take a look and see if you can solve this problem here. We know from D to E is 76 degrees, and from the measurement of angle B is 135. And I want you to see if, go ahead and just focus on 1A for time's sake. Find the measurement of ADC. ADC, hold on a sec. That's the measurement of arc AD to C, right there. So what would be the measurement of arc ADC? See if you can figure that on your own first. Remember, the measurement of angle B is 135, and you can see that that vertex of that angle sits on the outside of your circle. So if you want to try this on your own, go ahead and click play now. Otherwise, I'm going to go into how do you solve it. All right, so this measurement right here of this angle B is 135. So twice, if I take the measurement of ADC is going to be 2 times that angle measurement. So 2 times 135 is 270 degrees. I'm not going to do the next one. Let's go on. You're going to learn, I'm going to wrap this up. We are running out of time. You're going to learn some more inscribed angle theorems. So make sure you're taking notes as you go through this week's lessons. Take notes very carefully. Here we go. Week 11 key phrase assignment. There is an inscribed angle within this circle. And that measurement of angle ACB is 30 degrees. So that measure of angle ACB is 30 degrees. And I want you to find the measurement of arc AB. And explain how you got your answer. Explain how you got your answer for full credit. So again, explain how you got to your answer for full credit. And that's it. Have a great rest of your week, and let me know if you need any help this week.